Hi everyone, Miss Parsons here again. Now, in this video, I'm going to go over how to complete the square. And these are all the skills that we have done so far. Nothing new. So the only thing that we have not done so far is going from standard form to vertex form. And this is what we're going to be focusing on today. Now, one thing I want you all to recognize with vertex form is that, so again, I just converted this for you all. So the previous problem, I just decided just to convert it for you. And one thing you should notice that this has a perfect square within it. So right here, x plus 1 squared, all vertex forms have this set up here. That's how you know that it's going to be in vertex form. And you can also think about it as transformations, like, hey, this is going to go left 1, and then it's going to go up 3, and that's how you'll get your new vertex. And again, it's square because it's quadratic. So if you were using the box method, if you was to expand this out, this would be like x plus 1 times x plus 1. So the idea of a square is that you want to like multiply the same thing twice. So just like a square, like a 3 by 3, the same thing here, the length and the width is going to be the same. In this case, the binomial being multiplied twice. Okay, so all vertex equations have this form here. So again, it brings up the idea of what's a perfect square. So a perfect square is just a number / expression that can be written as the product of a number multiplied by itself. So it can be product, which is multiplication, of a number that's a number times itself, okay? So again, these are examples of perfect square parabolas. So we just did this on the other one. So the other one, like I said on the other one, you just being multiplied twice. So it's like perfect square. Like if this was a square, it's like length times width, the same thing. And then you can multiply this out, and you just get x squared plus 2x plus 1. Because this becomes x 1x plus 1x. Same thing here. If you have a perfect square, this is the same thing as saying I'm going to multiply this twice. And then you can just expand it out. But the idea is like the perfect square is being multiplied by itself. Okay, so it becomes x squared minus 12x plus 36. Okay. So this is all going to come together because it's very important to recognize that you will be creating this type of perfect squares when you guys are moving from standard form to vertex form. All right, now we have to do something called complete the square. That's going to be like our biggest thing, and we have to be able to know if these numbers are indeed perfect squares. So I'm going to put a star next to the ones that I want to review, and I'm going to have you all do the other ones. So is negative 16 a perfect square? Are there two numbers that can multiply to each other that would give me negative 16? So 4 times 4 gives me positive 16. If I multiply negative 4 times negative 4, I get a positive 16. So the only two numbers that multiply to give me negative 16 is negative 4 and positive 4. So I would say, no, this is not a perfect square. Okay, 9 over 16. You can kind of think about it as like taking the square root of both numerator and denominator, so this becomes 3 over 4. So if I wanted to see if these are perfect squares, to check it, if I do 3 over 4 times 3 over 4, I get 9 over 16. So yes, this is going to be a perfect square. And then over here, when you guys you think about it as like factoring, like what two numbers multiplies to 1 over 4, but adds to positive 1. And, you know, I think when I think of two numbers that's going to add to positive 1, I think of like a half plus a half. So, and then so a half plus a half gives me 1. And then if I was to do 1/2 times 1/2, I would get 1 over, because you do 1 times 1, 2 times 2, which is 1 over 4. So yes, this is going to be a perfect square. Okay, and then last but not least, see if this is a perfect square. So I just think of it as factoring. So 36 times, what two numbers multiply to 36 but adds up to 12? And that would be 6 and 6 times 6. So because these two numbers are the same, then you can definitely think of this as like, yes, these are two numbers. This is going to be a perfect square. And then this can be rewritten as x plus 1/2 times x plus 1/2. And because it's the same thing, you just rewrite it as x plus 1/2 squared. This is the same thing, so you think of it as x plus 6 squared. Same thing here, you just rewrite this as 3/4 squared. And that's like the expanded version. All right, so now I want you to go through the remaining here. And I just want you to tell me, is these perfect squares? And if so, rewrite them as perfect squares, like in that binomial, similar to how I have it here. Okay, check your work here. I cleaned it up a little bit. So again, when I factor this, two numbers that multiplies to 9 but adds up to 6, because these two numbers are the same, then I know that you'll have like a perfect square, okay? This one was pretty interesting. This was not actually factorable. So two numbers that multiplies to 4 but adds up to 2, it's not even possible because 2 plus 2 doesn't give me 2, and 1 and 4, no matter how you change it around, it's just not going to give you 2. So that was not even factorable, let alone a perfect square. This one right here was a perfect square. -2 came up twice. Two numbers that multiply to 4 but adds up to -4. That worked. And then the last one was a perfect square. Okay. So again, you can create those perfect squares. And one last challenge before we take our official notes is what number would you put here in order to complete the square? Meaning when I create like my x plus, what number will allow me to square this, okay? Now, I think of this as like our c value is missing. So you can kind of think about it as what is my c value, and my b value is given, which is -4. So I do need these two numbers here to be the same. So what two numbers, you can probably think about it as like what two numbers that are the same will add up to -8, and you can use that to calculate your new c value. Okay, so I'm going to have you push pause one last time and see if you all can figure out the new c values for all of these. And then we're going to get started with our official notes on completing the square. All right, I'll stop us midway, just a quick example. So for the first one, I got 16 and 9. And again, I'm starting from below. So I'll say like start at -8. What two numbers add to -8 that's the same? So 2 and 2, 3 and 3, no. -4, -4, yes. So now I just multiply those two, and that gives me my c. Same thing with 6. What two numbers that are the same will add up to -6, -3, and -3. And when I actually multiply these two together, I get 9. So I'm starting from the b value and just making my way up to the top. All right, finish up the last ones. All right, check your answers and here, and then you can just rewrite these as perfect squares. Yeah, product with perfect squares. Now, quick bonus, what would be your guess for the rule for finding like that new c value? All right, so let's take everything we have done so far to actually complete the square. So here are the steps for completing the square, and when I say complete the square, it's just basically you're moving from standard form to vertex form. So if you want to, you can feel free to just write down all the steps, and then we will be going over this example here. But make sure you all leave space. All right, so let's get to it. So if I want to convert from standard form to vertex form, step 1, it says separate your ax squared plus bx term from your c. Because remember, just like last time, we got to find a new c. Okay, so that's step 2. I'm ahead of myself. Okay, so I rewrite this as y is equal to x squared plus bx plus 8x. I'm going to use a space, so you can put like a space right there. Okay, and then minus 20, and I'm going to add another space there. Okay, so again, we separate these two terms from that original c value. Step 2, it says complete the square by calculating the new c. Okay, so remember, completing the square is just the idea like you want to create like a perfect square here. So I wonder if you all recognize that the formula to find your new C value is doing this here. Or you can kind of think about it as like, hey, I know that B is my 8. 8 is B. So what two numbers that are the same add up to 8? And that's going to be 4 and 4. So when I do 4 times 4, that gives me my new C value as 16. So I'm going to say y is equal to, in parentheses, x squared plus 8x. In that space, I'm going to put plus 16 minus 20, and then leave that space there. And if you're thinking about using this formula here, again, it's something else to memorize, but again, thinking about it this way is good, but you can also think of it as like C is equal to B, so it'll be 8 over 2, and then you square that. So you'll have 8 divided by 2, which is 4 squared, which is going to give you 16. So you can think about it doing it one of two ways, okay? Now, the next thing I'm going to do is balance. So the biggest thing is that you got to recognize is that you just add 16 to this equation, which means it's unbalanced. So if you add something to the equation, you have to subtract 16 from your equation. That way, if you was to like cancel this out, you go back to your original equation. And that's why it's very important to note that when you guys are looking at something in vertex form, this number is never your y-intercept because there's a balancing act that's happening here, okay? Your y-intercept is negative 20, and we're going to see that this is not going to be negative 20 at the end, obviously, okay? All right, so we have balance, that's step 3, and then step 4 is to factor out the perfect square. And the biggest thing is here we already factored it out. So what two numbers multiply to 16 but adds up to 8? And that's going to be x plus 4. So I can kind of just put the arrow there. Okay, so this would be y is equal to, now you can rewrite this as like x plus 4 times x plus 4. And again, these have to be perfect. It's like a square. They have the same length and the width. However, from our other problems, we have been rewriting this as x plus 4 squared. So I won't be mad if you just know, like, if I factor this, it becomes x plus 4 squared. Okay, and then step 5 says rewrite this in vertex form. So you can kind of think about it as like simplifying this. So negative 20 subtract negative 16 is going to be negative 36. Okay, so that would be like step 5. Okay. All right, and this is in vertex form. So where my vertex here is going to be negative 4, negative 36, and my axis of symmetry is going to be x is equal to negative 4. And just like we said at the beginning, the y-intercept can come straight from standard form is 0, negative 20. Never this, negative 36. That just means it's going to go as low as negative 36. All right. All right, let's do one more example together, then I'll have you all try it out. And just know, like, once you get really comfortable with this, the steps are going to go, like, pretty quickly, okay? All right, so first things first, we're going to separate this, separate the ax plus bx term. So I'm going to say y is equal to x squared minus 4x. I'm going to leave a blank here because eventually we're going to add something there. And then the c is plus 3. And then I'm going to put another blank there as a reminder to put something there. Okay? All right, step 2 tells me to complete the square. So this is where step 2 comes into play. We got to put a new number there. So you can memorize that formula. So you can think about it as negative 4 over 2 squared, which would give me negative 2 in parentheses squared, which would give me positive 4. So plus 4 would be my new c value. Or you could just think about it as like, okay, I know my b value is negative 4. What two numbers give me negative 4? This is you like dividing that into 2 equal parts. And then you can multiply these together to get positive 4. Just in case memorizing too many formulas is becoming overwhelming at this point. Okay? The next thing we're going to do is balance. So step 3 would kind of go here. So when I balance this, if I add 4 to this equation, I have to subtract 4. That way it can go back to the original equation if I was to like erase both my 4s. They cancel each other out. And then in step 4 is to factor out the perfect squares. It's pretty cool to have this here. So what two numbers multiply to positive 4 but multiplies to negative 4? And that would be x minus 2, x minus 2, which simplifies to x minus 2 squared. So this is that perfect square right there. And then I can, so this is step 4 right there. And then step 5 is just the idea of rewriting this in vertex form. The only thing that has to be done is that these two have to be simplified. So I would write this as minus 1. Whew. Step 5. All right, cool. And that is that example. So that's just us doing it right there. All right, so you have this problem here. I would like for you all to convert this to vertex form. And then you can push play to see how did you do. All right, and that concludes converting from standard form to vertex form. Make sure you all check your answers. Continue on with this practice. There is a lot of steps here, but once you get the hang of it, you'll see how quickly it goes. All right, great job today, and come to me with any questions, and I will definitely see you guys on the next video. Bye, everyone.